Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning Chapter 3 Matrices for Class 12. So this is one of the very easiest chapter in Class 12, and this is also an important chapter where we'll be applying everywhere. This chapter is very important, so keep that in mind, and this is one of the very easy chapter. So now let's move on to the definition first. Now I'm going to give you the definition for matrix. Matrix is singular. Matrices means plural. Okay, so here definition. A matrix is an ordered rectangular array of numbers of functions. The numbers of functions are called elements or the entries of matrices. So the general form for any matrix is this one. This is row and this is column. So the first number over here will represent the number of row in which it is present, and the second number represents the number of columns. So this is a general form for any matrix. We will be using these kind of representations to do this. So here now any form will be given as Aij. Hereafter we will come across in the first exercise as Aij only. I represents the number of rows. That is the representation for this. That is, this will be, when it is Aij, it means I represents the rows, J represents the columns. So here the number 1 represents the first row, and here it represents the first column. Here also first row, second column, first row, third column, and etc. First row, nth column, just like that. So here also it is like that only. So Aij means it represents the number of row, in the number in which it is present. J represents the number of columns in which it is present, and here this will be termed as order of matrix. So here it is m by n. This will be read as m by n. It is not m into n or m cross n. It is read as m by n. So here m represents the number of rows. So since this is a general form, we will not know how many rows it has. No, so only I have represented with m and the number of columns by n. So m represents the number of rows and n represents the number of columns. So now let me give you all an example. So I'm naming the matrix as A. A is equal to 1, 2, 3, 4. So any entries is a matrix. So if we write like this, it will be a matrix, and this will be 2 by 2. See here I have 1 row, 2 row. So 2 rows and 2 columns here. So I can have any number of rows and any number of columns. B matrix is equal to 8, 7, 10, 21, 15, 20. So this will be 2 rows is there. So I will write 2 by. So how many columns do I have? 3. So this will be 2 by 3 matrix. So this is also very important to know the order of matrix. So now let me teach you all the types of matrix and order of matrix. First, we will learn the order of matrix. Already I taught you what is order of matrix, isn't it? So it is the, I said, m by n. This only is called as the order of matrix. Order of matrix is equal to number of rows into number of columns. This is the general form for any order of matrix. So this number of rows we represented as m. No, so only m by n. So n will represent the number of columns. So here, for example, I have given 1972. So this has 2 rows and 2 columns. So I have written 2 by 2. So one more example let us take. So in this, what is the order of its matrix? So I have 1, 2, 3. 3 rows and 1, 2. 2 columns. So this is the 3 by 2 matrix. This is called 3 by 2 matrix. Now let us learn types of matrices. So in this types of matrices we have 9 types of matrix. So this is very important, and if we know these types of matrices we can answer any question. So here we have to know the order of matrices also. That is important for some type of matrices, not for all. So now first let's learn about column matrix. If a matrix has only one column, then it is called column matrix. That only I have given. No, this is a keyword. If only one column is there, then the general term for this will be A is equal to I1 by m into 1. This is the general form, and this will be, see, it can have n number of rows. It can have n number of rows only, but the column is only 1. So therefore this is a general term or general form for any column matrix. And this here example I have given 1 2 3, and this will have three rows and only one column. So this is 3 by 1 matrix. So here the order of matrix is important. So next we will learn about row matrix. Row means what? There we learnt column matrix. Column matrix has only one column. Then now here we are learning about row matrix. So if it is row matrix, it will have only one row. That is called a row matrix. So if it has only one row is present, then it is called a row matrix. What will be the general form for row matrix? It will be A1J 1 by n. So it can have n number of columns, but it should have only one row. That is called row matrix. So the example I gave here, it is 1 by 3 matrix. So always my number of rows should be only 1. Then it is called row matrix. Third type of matrix is square matrix. In general term, what is a square? It should have all the sides equal, isn't it? Every side should be equal. Then it is called a square. So here square matrix also same. Every sides, when we see, every sides will be equal. That is, the elements in every sides will be equal. So here the number of rows should be equal to number of columns. Then it is called square matrix. So if you count the elements also, when we go in rows 1 2 3, three elements we have. So if we count in columns also 1 2 3, columns only, 3 rows or 3 columns only we have. So then it is called a square matrix. So when the number of rows is equal to number of columns, then it is called a square matrix. And the square matrix is very important, where we will be learning further. Mostly square matrix only we will be learning. So we should be very thorough with what is a square matrix. We have lots to study in square matrix. This is just a beginning. Fourth type is diagonal matrix. Diagonal matrix here means only in the diagonal, that is when we have A11, A22, A33, only in such entries we will have some numbers or constants. Other entries will be 0. So that is, if all non-diagonal elements are 0 and only the diagonal elements have some constant, then it is called diagonal matrix. So when we have such a way, then it is called diagonal matrix. Fifth type of matrix is scalar matrix. If its diagonal elements are equal and non-diagonal elements are 0, then it is called scalar matrix. For example, when we see here in this example, every numbers in the diagonal, that is diagonal means only this one, okay? We should not see here, not this way. We have to see over here. So when we take here 3 3 3, when every numbers in the diagonal are same, then it is called a scalar matrix, and other elements or other entries should be 0, then it is called a scalar matrix. It can be either negative or positive, but it should be the same number. Everything should be equal. So that only they have given here. I should be equal to J, then it is called a scalar matrix. I is equal to J means what? I, J, no, this is the general form. So Aij is equal means A11, A22, A33 only is possible. So therefore, if it is like that, then it is called as scalar matrix. See, there's a difference between diagonal matrix and scalar matrix. Diagonal matrix means the numbers in the diagonal will be different. Okay, in scalar matrix, the numbers so in the diagonal entries will be equal. That is, we can take only one number, not two or three numbers. For example, if we have 3 over here, and if it is minus 3 over here, what type of matrix it is? It is diagonal matrix. It is not scalar matrix. Okay, so when every elements that is in the diagonal are equal, then it is called scalar matrix. Sixth type of matrix is identity matrix. If diagonal elements are 1 and non-diagonal elements are 0, then it is called identity matrix. This type of matrix is very, very important. Identity matrix, scalar matrix and square matrix is very, very important. You have to know. So now once more I will just explain. If only the diagonal elements, that is when I is equal to j, in such cases when aij, if I is equal to j, then in that place and all only one should be there, not any other number, and other non-diagonal elements should be 0. Then it is called identity matrix. So when we take in 2 by 2, 1 0 0 1, this is the identity matrix. So when we take in 3 by 3, in 3 by 3 matrix, 1 0 0 0 1 0 0 0 1, this is the identity matrix from 3 by 3 matrix. So when we take for 4 by 4, 4 by 4 means it will be 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. See, when we take here, this is A11, this is A22, this is A33, this is A44. So all the diagonal elements are 1 and other non-diagonal elements are 0. Then it is called identity matrix. So next we will move on to zero matrix. Here zero matrix means 0. Every element is 0. No, that is called zero matrix. If all element in a matrix is 0, then it is called zero matrix. See, and one more important note is that 0, this is 1 by 1 matrix. Fine. So here I have 1 by 2 matrix, 1 by 2 matrix, 0 0 0 0. This is 2 by 2 matrix. Anyway, the entries over here, everything is 0, but these matrices are not equal. That is, 1 by 1 0 matrix is not equal to 2 by 2 or 1 by 2 matrix. This is not equal. So why? Because the orders here, it is different for 1 by 1 and 2 by 2 matrix. If the order is same, then we can say that 0 matrix is equal to 0 matrix. Since the order is different, we are saying the matrix are not equal. So this had to be very, very important note. This was asked as one word answer in previous years. So this had to be noted. Eighth type of matrix is unit matrix. Unit matrix means every element should be 1. If all elements in the matrix is 1, then it is called unit matrix. For example, I have given A is equal to 1 1 1 1. It is 2 by 2 matrix. Therefore, it is unit matrix. So if it is 3 by 3, 1 1 1 1 1 1 1 1. So this is called unit matrix. So if it is 1 1 1 1 1 1, it is 2 by 3 matrix. Here also it is called a unit matrix only. So one more example, if we take 1 0 1 1 1 1. Is this a unit matrix? No. It is not a unit matrix. Why? Because even element is not 1, then it is not called as unit matrix. Every element should be 1. The elements should be 1 only. Then it is called unit matrix. The last type of matrix is equal matrix. Equal matrix means the two given matrix will be equal. Let A is equal to Aij m by n and B is equal to Bij m by n. A and B are said to be equal if and only if they are of same order. Order of matrix we learnt, no? That should be same. If each element of A is equal to the corresponding element of B, corresponding element, I will teach you with the example. A, and that is Aij is equal to Bij for all I and j. So for example, you consider this matrix A and B. Here I have 1, 2, 3, 4. Here also I have 1, 2, 3, 4. So corresponding elements means here it is called as Aij. No, so it will be A11 and here it will be B11. If A11 is equal to B11 and B12 is equal to A12, A21 is equal to B21 and B22 is equal to A22, then it is called equal matrix. Fine. So one more is here. See, 2, 1, 4, 3. So every elements in A is equal to every elements in C. But is the corresponding elements equal? See, I have here 1. Here it is 2. So A11 is 1. Here A11 is 2. There itself it is not equal. So therefore I will say these two elements are not equal. That is, these two matrices are not equal. For equal matrix, corresponding elements should be equal. If not, it is not equal. Every element is present over here. All the entries are same, but the position is not same. So therefore, they are not equal matrices. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.